Alright, I'm pretty excited. I just figured out subtraction, okay? As dumb as that sounds, I finally figured out what makes sense. Okay, hold on. I should have done this first. Okay. Alright, so everybody who's just like, okay, addition and subtraction, it's easy stuff, it's elementary, you know what I mean? But I'm doing these math workouts, I do the calculations all the time. I gotta look at that. I do these calculations all the time, almost every day. I get on my math app and I put in like 3 minutes where I've moved up, 2s, 3s, 4s, 5s, 6s, and now I'm just doing 2 through 9, and I'm doing addition and subtraction, but I'm including the second set, 11 through 20, and so I'm going through it, and I go through it every day, and addition is pretty easy because on the number line, you're just moving up, right? So I can't really move this. Anyway. 2 plus 4. Well, on the number line, 0 and 10, you've got 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. All you're doing is from 2, you're just adding 4, you know what I mean? You're just going this way, 1, 2, 3, 4, to get over here to 6. Basic, right? And it's gonna work that same way with the first set and the second set, 1 through 10 and 11 through 20. Addition's easy to understand like that, okay? Because that's all you're doing. You have the subject, 2, is what you're starting at, right? Then you have the verb. I'll just do whatever. You have your subject, your verb, and your predicate. Fuck that up. I'm doing this now. I got the colors. I might as well use them. Alright, subject, verb, predicate. Your subject is what you're starting with, right? You're starting at 2. What are you doing to that 2? You're going to be adding something. Okay, so on the number line, you're going up. But what are you going up by? 4. Okay, subject, verb, predicate. Pretty easy to understand. But subtraction gets weird. Okay. With subtraction, (17 minus 9). Okay. With addition, you have the names of them are the addend plus the addend equals the sum. But with subtraction, at least my college level math book didn't tell me the names. It just told me this was an algebra problem. This is, you're going to add 9, is equal to x. Is equal to x. You add 9 to both sides. And you subtract x from both sides. You know what I mean? And so you're left with 17. I don't remember how it works out. No, okay, I fucked up. 17 is equal to x plus 9, right? So in this instance, subtraction's an algebra problem. it's not 17 minus 9 equals the difference. Okay, that's the official word. You look it up in Merriam-Webster's dictionary. Difference is the result of subtracting, which is its own funny thing. So this just makes subtraction algebra. It makes it addition, right? Because you now have an addend plus an addend is equal to 17. You just don't know what one of those addends is. So one way of thinking of subtraction is algebra. Anyway, here's one way of thinking about it. What confused me was that the result of subtraction is called the difference. Now, difference means that subtraction doesn't exist. Because difference on a number line, if you're looking at the difference, this isn't 17 minus 9. This is what's the difference between 17 and 9, right? So, to subtract would be to take away from 17. So 17 minus 9 is going to be 8, right? You got to go down here to get to 8. So here's the weird part, because 17 minus 9 is 8. But the difference between 17 and 9 is 8, right? 9 plus 8 is 17. Okay, so are you subtracting 9 from 17 to get to 8? Or are you looking at the difference between 9 to 17? Right, so what the hell's even going on? I was under the impression that subtraction didn't exist, that the word subtraction was wrong, because what you're doing is you're finding the difference. We have two different answers here. 17 minus 9 is 8, but the difference between 9 to 17 is 8. So that's what I was getting so confused, because I'm like, subtraction doesn't exist. You're just finding the difference between the two numbers, because subtraction is one thing, but the difference is something else. Boom. Okay? So we now have an addition problem. 9 plus what is 17? We now have a subtraction problem. 17 minus 9 is 8. And then we have a difference scenario on a number line. The difference between 9 and 17 on a number line is 8. So, okay, we now have 3 different avenues to go down when we're looking at subtraction. It's not just addition, 1 plus 1 equals 2. Now we have 3 different ways of thinking about the way that something is being subtracted, right? I later on found out that subtraction does have names. I was wrong. So you have the subtrahend minus the minuend equals the difference. So this is the subtrahend and this is the minuend, which means that 17 is in fact our subject the subject of our sentence. Okay? We are subject, verb, predicate. We are subtracting 9 from 17. So our answer is 8. 17 to 8, right? But I was still getting tripped up. I was still getting tripped up with things, because when I'm on my app and I'm going through and I'm doing the addition stuff, like, okay, with addition I'm learning the relationship numbers have. So, 6 and 7. The way that I describe relationships with numbers is like 6 plus 7 equals 13. minus 7 equals 6. 7 plus 6 equals 13. Minus 6 equals 7. The relationship between these three numbers when they're being added. So when they're being added or subtracted, 6 and 7 are in a relationship with 13 because those three numbers together are intertwined, right? They form a relationship together. So whether you're adding 6 to 7, you're getting 13. But if you're subtracting 7 or 6 from 13, you're getting the other one. And so these numbers are in a relationship together. That's why things like 3 plus 4 is equal 7. But then you say, oh, what's 7 minus 4? It's 3. Like, you don't even have to think about it because you know the relationship between those numbers, right? 2 plus 3 is 5. Well, 5 minus 2 is 3. You know that the 2 and the 3 and the 5 work together. What I was having a hard time doing was coming up with the relationship. So there's a fourth avenue, okay? We've got algebra, we've got subtraction, we've got difference, and we've got relationship. Because when I'm doing subtraction problems, it'll come up, 14 minus 9. And you say, okay, what's the relationship that 9 has with 14? It's going to be 5. But it's, okay, so now there's 4 different ways of thinking about the way that these numbers interact with each other. And I was still getting tripped up because some of the memorization is popping in there. I was struggling with my 11s, my 15s, 8 plus 7 being 15. I would be going through on the app and it says 15 minus 7 and I would just blank out. And I'm like, wait a minute, what the fuck is 15 minus 7? And I gotta think about it because on the number line, I can think of the 15, and okay, well, how do I think about this? Is this 15 minus 7? Well, I'm kind of struggling thinking about what that actually is. So what's 7 plus what is 15? And okay, what's the relationship that 7 has with 15? What's the other number? So you've got these different avenues, and you can find which one works best for you. But subtraction, man, it was still just getting to me that I was still coming up short, and I couldn't figure out why. I can sit here and I can draw out little circles. 8 is 5 little circles plus 3 little circles plus 7, 5 little circles plus 2 little circles. And when you add them up, those 3 little circles from the 8 and those 2 little circles from the 7 mend together to make another 5, so now you got 15. I'm drawing. If you look at my whiteboard before I erased it, that's what was on here because I'm trying to figure out, conceptually I can see that this works, but when I'm doing a subtraction problem, on my app or whatever, I still just get tripped up. I find myself resorting to the relationship avenue of thinking about things. 13 minus 6. I'm wait a minute. That's going to be 6 plus what to get to 13? I can't. I was struggling with thinking of the way that the whole number, the subject of the sentence, the 13, is subtracting the 6. I was having to change the subject to the 6 and turn it into an addition problem or into a relationship idea to be able to solve that equation. But trying to think of it as the actual subject of being 13, subtracting 6. I was struggling with it. I couldn't figure out why. But I cracked the code. Okay. The one concept that you have to know is that any number can be represented by the addition of any other two numbers. So, to make it easy, I'm just going to do 10. 10 is 9, 1, 8, 2, 7, to get to a 10, 10 can be broken up into any of these. You know, there's an infinite way of representing any number. You know what I mean? 1 can just be 3 minus 2. 1 can be negative 2 plus 3. 1 can be 257 minus 256. There's an infinite way of representing any number. Any number. So 10 can be represented as a 9 and a 1. So, you know, if you're 7 plus 10 is also 7 plus 9 plus 1. Right? So you can just break numbers up. You can just break numbers up. I've used that concept. That's one of the concepts that I use. So when I'm doing 13 minus 6, 13 minus 6 is equal to 13 minus 3 minus 3. Okay. What you do is you take the subject 13. You break that 6 down into whatever two numbers is going to give you a 10. So that 6 can be represented as a 5 and a 1, a 4 and a 2, and a 3 and a 3. So since I'm dealing with 13, the 6, the counterpart that I'm going to use is the 3 and the 3. You know what I mean? 6 is 3 and 3. So since I'm doing 13 minus 6, you break 6 up into the counterpart of whatever 10 to get you down to 10. You're left over with another 3, and then 10 minus 3 is 7. So this changes into 10 minus 3 equals 7. Right? Okay. All right. I'm starting to get it. That's the main concept that I started using to get my subtraction down, because it's always the subtraction that is a double-digit number, the second set, 11 through 20. It's a second set number that jumps the 10. You know what I mean? If I'm just doing 9 minus 7, I mean, that's 2. Like, come on. Everybody knows that. But when I'm doing 15 minus 8, wait a minute, I gotta think about it. 15 minus 8, you know, and I can try to do like the addition problem backwards, and 8 plus what, you know, to get to 15 is 7. But no, like, fuck that. I'm not gonna rely on the addition. I want to understand how you take the subject 15 and subtract 8 from it, you know what I mean? So this is how I started doing it, because 15 minus 8, that 8 can be represented as a 5 and a 3. So I'll write this out. 15 minus 8 is 15 minus 5 minus 3, which is 10 minus 3, which is 7. Right? So 15 minus 8, you just break that 8 up into the 5 and the 3. Because that 5 will get you down to 10, and then you take the second number and you subtract from there. Because 10 can be broken up into any of these. Okay, cool, I'm starting to get it. But there's one more thing that I'm still struggling with. Because here I am, I'm doing this. I started learning it, I got back on my app and I started working with it. And the problem I'm running into is the fact that the number line. The number line is always 20, 10, 0, negative 10. You know what I mean? The number line's always 0, and the addition, the positive numbers, are always on the right, and the negative numbers are always on the left. So when you're adding, that's fine, because 2 plus 5, well, you got 2 here, and you're adding 5, and you can go up. So when you read 2 plus 5, you've got the subject, the verb, and the predicate. So that your subject is 2, and you're going up to the right. But when you're subtracting, our system writes it as 2 minus 5. They still write it left to right. But the number line, if 2 is my subject, I'm subtracting 5. I read this left to right, 2 minus 5. But on the number line, I have to subtract 5. I have to go this way. And that was fucking with me. Okay? Adding is fine. You're just going to the right because you read it left to right and you add left to right. But subtracting, you read it left to right, but then you subtract it right to left. Okay. So, I flip the number line in my head. Fuck it. Why can't 20 be over here, and 10 be over here, and 0 be over here? Because the systems that I use, apps, and the way that the world works, it's always going to be written like this. It's always going to be written subject, verb, predicate, with your subject being on the left and you read it left to right. That's just the system. I could start writing it in my own math books. If I wrote a math book, I could write this 2 minus 5, and we would know that when you would write it, if it's an addition problem, you would write it this way. If it's a subtraction problem, you'd write it this way, and you would know to read right to left because you're moving on the number line to the left, right? I can write in my own math books, and I can try to change the way that we write subtraction to make it more visually pleasing to understand it better, but I doubt that's ever going to happen. So when I'm reading this left to right, in my head I have to flip the number line left to right, because 2 minus 5 is now 2 minus 5 to get me to -3. I gotta flip the number line in my head. So when I come up with 13 minus 7, equals what? I've got 13. 1, 2, 3, 4, 5, 6, 7, right? And I read it this way, so I'm going to go down this way. That's just a place marker. So, yeah, and then you break this 7 up into its counterparts 3 and 4. So 13 minus 3 gets you down to 10. And then 10 minus 4 gets you down to 6. So 13 minus 7 equals 6. Okay. I understand subtraction now. This is how I learn. I don't learn the way that the books teach me to memorize what the fuck these things mean or what they are. I gotta play with it, and I gotta find how it makes sense for me. Okay, which I think everybody needs to do for any subject, especially math. Because math is always one of those subjects that people can't understand. Well, it's because they only teach it the way that they teach it. They don't teach it the way that you learn it or the way that you understand it. I've been playing with numbers like this. I just play with this shit. So that I can, because once you understand it, you don't have to memorize anything. I understand that, things fall when you drop them. Nobody has to remind me that happens. But I have to be reminded what 7 plus 8 is, because it never clicked with me as a kid. Well, it's because I never understood it. Once you understand it. So now I'm sitting here, I'm on my math app, and I just got it on subtraction. I'm not doing addition. I just got it on subtraction. And each one of these, as I'm doing them, I can see now the subject, 13, minus the verb, minus 7. Okay, break that 7 down into a 3 and a 4. You go from 13 down to 10, and then 10 minus 4 gets me down to 6. I've got a backwards number line. I'm working left to right, and I'm breaking it down into the two numbers that get it down to its 10, and then whatever the other counterpart number is. Yeah. And so I can, when I look at the subtraction problem now, it's not, oh wait, what's that relationship between a 7 and a 6 and a 13? Oh, what, instead of changing the subject to the 7, like 13 minus 7, what is that? Oh, well, I got to change the subject to the 7 and say 7 plus what equals 13. Think of it as the addition way. Well, no. Take the subject, 13, and subtract 7 from it and understand why it goes down to 6. Cool. Subtraction. I get it. Thanks for watching.